Hello guys, welcome back. So today we're going to start talking about parallel and perpendicular lines. And as we get more through it, we'll see some different things about it. So first up is parallel lines. So parallel lines are two lines that are never going to meet. So they're going to look something like this on your coordinate plane. I'm going to use two different colors to draw two different lines. Red and a blue. As they go on forever and ever, they're never going to touch, and this space between them is always going to be the same amount. Okay? So, getting into parallel lines. These are two lines in the same plane that never intersect. Never, not once. They're not going to touch. They're not going to cross at any point. So, non-vertical lines are parallel if and only if they have the same slope. So if my m is the same, my m is equal to the m of the other one. Okay? So that's why we're going to need to use point-slope form, and we're going to need to use slope-intercept form so we can compare them and see if they're going to be parallel if they were graphed. So, moving down, the steps to writing a parallel equation is we're going to identify the slope from the original equation. So that's first, identify the slope. Then we're going to use the slope and a given ordered pair to find the new equation, either in point slope or y equals mx plus b. So your final equation, no matter what, needs to be in y equals mx plus b format, because point slope form isn't what we would be graphing from. So what we need to do is put it into how we would graph it. Okay? So, in my first example, we need to write an equation of a line that passes through this given point and is parallel to this line. So, looking at this line, my slope in this line, y equals mx plus b, I'm going to rewrite that on top. Y equals mx plus b. Okay, my m in this equation, connecting m to the number underneath, is going to be -2. So, in my new line, m is going to equal -2. Now, I have this point. I'm going to start by putting it in point-slope form. Then I'm going to convert it into slope-intercept form like we've been practicing. So, I'm going to write my point-slope form. Y minus y1 equals m times x minus x1. I'm going to label this point as x1, y1. And then I'm just going to plug everything in. Y minus y1 is +2. M is -2. X minus -4. Well, that becomes x plus 4. Now, to move it into slope-intercept form, I have to distribute my slope to what's in the parentheses. So I'm going to rewrite this. Y minus 2 equals -2 times x, -2x, -2 times +4, -8. Now, my last step, I have to get y by itself. So I'm going to add 2 to both sides. And my final equation, y equals -2x minus 6. All right? So we know that this is going to be parallel because our slopes are the same. And they're never going to touch because our y-intercept is 0, 1. And my other one is 0, -6. All right? So we're just going to go through a couple of these examples. And hopefully it'll get a little bit easier as we go. Now, in my first equation, I can't even tell exactly what the slope is at the beginning. No problem. I just have to put that into slope-intercept form. So to do that, I need y by itself on the left-hand side. I'm going to add 3x to both sides. Now I have y equals 3x plus 5. That's my original equation. My slope in this, if I were to write this in y equals mx plus b form, is going to be 3 connects with my m, so m equals 3. Okay, then I'm going to take my point, the given point is 8, 3, and I'm going to label it x1, y1, and I'm going to plug all of this into point slope form. So y minus y1 equals m times x minus x1. Just going to start plugging things in. Y minus my y1 is 3. My m is 3 times x minus x1 is 8. First step to get this into slope-intercept form, I'm going to distribute my slope to what's in the parentheses. Y minus 3 equals 3 times x, which is 3x. 3 times negative 8 is negative 24. Okay, now last step, I'm just going to add 3 to both sides. Okay, y equals 3x minus 21. Okay, and these two lines are going to be parallel lines. They're never going to touch. All right, I've got a couple more examples, and then we're done for the day video-wise. Moving down, line A passes through the points negative 5, 3, and negative 6, negative 1. Line B passes through the points 3, negative 2, and 2, negative 7. Are they parallel? So, to determine if these two are parallel, we have to find the slopes of each. I'm actually going to change this highlight to a different color. There we go. Just do blue. Okay, now I'm going to find the slope for both of these and see if they're the same, then the lines are parallel. So remember, slope formula is m equals y2 minus y1 over x2 minus x1. Okay, so let's start with my blues. Let's go back. Let's start with my blue points. There we go. So I have negative 5, 3, and negative 6, negative 1. I'm going to label these x1, y1, x2, y2. So m, using that formula up there, y2 minus y1, negative 1 minus 3 over x2 minus x1, negative 6 minus negative 5. Negative 1 minus 3 is negative 4. Negative 6 minus negative 5, which becomes negative 6 plus 5, is negative 1. So my m for the blues, negative 4 divided by negative 1 is positive 4. All right, now going into my greens, I have 3, negative 2, and I have 2, negative 7. Labeling x1, y1, x2, y2. M equals negative 7 minus negative 2 over 2 minus 3. Negative 7 minus negative 2 becomes negative 7 plus 2, which is negative 5, over 2 minus 3 is negative 1. So the slope on this one, negative 5 divided by negative 1, is positive 5. Are these two the same? No, they are not. So my final answer to this question here, no, they are not parallel because my slopes aren't the same, which means at some point they are going to intersect. All right. Now, moving down. Write an equation of the line that passes through the given point and is parallel to the given line. Okay, so y equals 3x plus 6. Remembering my m is going to be this 3. And my given point is this. So I have m equals 3. And I have x1, y1. I'm going to plug this all in to my point slope formula. Y minus y1 equals m times x minus x1. So y minus 7 equals 3 times x minus 4. I'm going to distribute. Y minus 7 equals 3x minus 3 times negative 4 is 12. Last step, I just have to add 7 to both sides. So y equals 3x, negative 12 plus 7 is negative 5. And that is my equation of that line. Nice and simple. I just have to put it into point slope form and then solve for y. All right. Moving to the next one. Y plus 2x equals 4. I have to put this into y-intercept form, or slope-intercept form, I'm sorry. So to do that, I'm going to subtract 2x from both sides. So I have y equals negative 2x plus 4. This means my slope, my m that I'm going to be using, is negative 2. Now I have negative 1, positive 2 as my x1, y1. And I'm just going to plug that into point slope form. So y minus y1 equals mx minus x1. I'll plug in all my things. Y minus y1 is 2. My m is negative 2 times x minus negative 1. Minus a negative becomes plus 1. Next step, I'm going to distribute my slope into the parentheses. So y minus 2 equals negative 2 times x is negative 2x. Negative 2 times 1 is negative 2. And lastly, I'm going to add 2 to both sides. And y equals negative 2x. Negative 2 plus 2 is 0. Or I can simply write this as y equals negative 2x. All right, that's the basis of what we're doing here. We're just finding that slope, we're plugging it into point slope, and then we're solving for y. All right, last part of today's lesson. If I can get my iPad to work, there we go. So now, we have to determine if any of these are parallel. So, what we're going to do is find the slope for line A, the slope for line B, and the slope for line C. All right, so I'm going to take my black pen. I'm going to rewrite the slope formula, y. M equals y2 minus y1 over x2 minus x1. Then I'm going to split my space into 3 parts. And we're going to find the slope for each. So first, I have line A. I have negative 1, 1, and 1, 3. I will label my points x1, y1, x2, y2. Now, my m, I'm just plugging it into this formula up here. So, y2 minus y1, 3 minus positive 1, x2 minus x1, 1 minus negative 1, that becomes plus 1. So, 3 minus 1 equals 2, 1 plus 1 equals 2. So my slope of the first line is 1, okay? Now my second line. My second line is red, line B is red. So I have 3, 4, and 0, 2. I'm going to label my points x1, y1, x2, y2. M equals y2 minus y1, 2 minus 4, over x2 minus x1, 0 minus 3. 2 minus 4 is negative 2. 0 minus 3 is negative 3. So it becomes 2/3. All right. And my last line, my C, I'm going to do in green. I have 0, 1, and 3, 3. So now I'm going to label these lines x1, y1, x2, y2, m equals y2 minus y1, 3 minus 1, over x2 minus x1, 3 minus 0, 3 minus 1 is 2, 3 minus 0 is 3, so that's 2/3. Now, if any of these lines are parallel, then our slopes are going to be the same. If I look at these, my slope is the same for line B at 2/3 and line C at 2/3. So, lines B and C are parallel lines. Parallel lines. Sorry, my pen doesn't want to work today. All right, so that is today's lesson on parallel lines. If you have any questions, make sure to leave a comment on the Google Classroom or email myself, Ms. Kirschbaum or Ms. Gates, with any specific questions you have. Make sure you are asking them and you are not just saying, I don't understand anything. We can't help you if you don't understand anything. Tell us something specific that you don't understand. We're here to help between the hours of 8 and 3. And if you need anything, just let us know. Have a great